Welcome to Module 9. Last module we looked at for each sequential processing, one item at a time. This module, we speed it up. Parallel for each takes the same collection and processes multiple items at the same time on different threads. The main flow waits for all threads to finish before continuing. It's faster than for each when items are independent, but order is not guaranteed. Let's see what that means in practice. Here's the scenario. An order has 50 line items. Each item needs a price from a partner API. In serial, using for each 50 API calls, 200 milliseconds each, equals 10 seconds. With parallel for each 10 threads calling the API at the same time, each item takes 200 milliseconds. Total time drops to about 2 to 3 seconds. Multiple items on multiple threads, concurrently. That's the speed gain. The trade-off: order is not guaranteed. Whichever thread finishes first, its result goes first in the output. Click Parallel for each and look at the real fields. Because they are not the same as for each, you get display name, collection, what to split up. Empty means the payload. Timeout, milliseconds to wait on a single item before giving up. Max concurrency, how many threads at once. Target, which lets you write the result into a variable instead of overwriting your payload. And target value, which is pre-filled with hash payload. Notice what is missing. There is no variable name field here at all. The item is the payload, same as for each. None of these are mandatory, but max concurrency is the one you should always fill in. Leave it empty, and Mule will try to run every item at once, and that is how you starve your own thread pools and get throttled by whoever you are calling. Before parallel for each, the payload is the array. During processing, each item runs on a separate thread. After processing, Mule aggregates the results back into an array in the payload, but the order may not match the input order. If thread 2 finishes before thread 1, its result appears first. That's usually fine for independent operations, but if you need guaranteed order, use for each instead. Transactions are the gotcha. Parallel for each inside a transaction doesn't actually run in parallel. To maintain transaction consistency, Mule degrades it to sequential. It runs just like for each. So if you're inside a transaction and you expect parallelism, you won't get it. All items must succeed or the transaction rolls back. The parallel speed gain is lost inside transactions. Naming parallel for each. Make it clear that this is parallel processing. Parallel process orders, concurrent transforms. Don't just call it for each parallel. That's confusing. And use the same variable naming as for each singular form of the collection. Good practice. Use parallel for each for independent work, calling multiple APIs, querying different databases, transforming unrelated items. Always set max concurrency. Without a limit, Mule can spawn a thread per item and starve your other flows. Bad practice: using parallel for each when items depend on each other. If item 2's processing depends on item 1's result, the parallel threads will corrupt your data or create race conditions. Use for each instead. When not to use parallel for each: if items depend on each other, don't use it. If you're inside a transaction and expect parallelism, restructure, complete the transaction first, then parallelize outside. If you're processing millions of items, parallel for each can spawn too many threads. Use batch instead. And if order must be preserved, parallel for each won't guarantee it. How many parallel for each scopes? Usually one per independent operation. If you have 3 parallel scopes in the same flow, each processing different data, that's fine. But nested parallel loops multiply the thread count dangerously. Avoid nesting. Here's the performance scenario. An order with 50 items needs pricing from a partner API. Item 1 waits for the API, item 2 waits, item 3 waits. Serial: 50 items times 200 milliseconds equals 10 seconds. With parallel for each and max concurrency of 10, you fire 10 API calls at once, wait for them to finish, then 10 more. Total time, around 2 to 3 seconds. Much faster. The trade-off: the results come back in random order as threads finish. The questions about parallel for each. 1. Does it preserve order? No. Results aggregate in thread finish order, not input order. 2. Why set max concurrency? To protect your thread pool and downstream systems from overload. Without it, Mule spawns unlimited threads. 3. Does it work in transactions? Technically yes, but it degrades to sequential. Use for each if you need a transaction. 4. One item fails. What about the others? Other threads keep running. Eventually the main flow sees an error, but some results may be preserved. 5. Items communicate with each other? No. Each thread has its own event copy. Variables set in one thread don't affect others. To recap, parallel for each processes items concurrently on multiple threads. The main flow waits for all threads to finish. Results are aggregated but order is not guaranteed. Max concurrency limits how many threads at once. Inside a transaction, it degrades to sequential. Use parallel for each for independent items only. Next module, try scope, how to catch and handle errors.